Hi, everybody. Welcome to the lesson for Wednesday, April 8th. This corresponds with section 8.2, which will teach you how to use functions involving E. So this lesson, kind of similar to the last one, is going to involve a couple of graphing aspects, and I'm also going to show you a couple of new things to punch in on your calculator. So if you have your graphing calculator handy or something similar, that would be useful to get at this time. So what I'm going to introduce you today is the natural base E. Natural base E is not a variable. E is actually representative of an irrational number. It doesn't get as much acclaim as pi, but it's kind of the same type of number where it's this number that goes on infinitely without any sort of pattern or repetition. E is used with all of these exponential and logarithmic functions. So you can see here at the box at the top, E is approximately 2.718, blah, 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 all these different numbers that will pop up. So we're going to be using E in a bunch of different ways throughout the chapter here. The biggest thing you need to get into your head is when you see this letter E, it is not a variable. It actually represents a number. So what we're going to do are three different things here. We're going to look at just reviewing some basic exponent properties and involving E at the same time. Then I'm going to show you how we can actually evaluate problems that involve E using the calculator, and then we'll take a look at a couple of things graphically with E as a natural base. So we look at the first handful of examples here. All we're going to do, and the key word in these directions here is the word simplify. So if I tell you to simplify, we're not actually punching this into the calculator. We're just going to use our knowledge of simplifying exponents and all those sorts of things here to get it down to one base, get it down to just one E in the problem. So let's do some quick review here of our exponent properties. So here in 1a, we have E squared times E to the fifth. We have the same base E. When we have the same base being multiplied, we take the exponents and add them. So E squared times E to the fifth is same thing as E to the 2 plus 5 power, which means this simplifies to E to the seventh. Example B, we have 12e to the fourth over 3e to the third. First things first, when you have 12 over 3, you have those coefficients out front, you just do regular division. 12 divided by 3 we know is 4. With the e's, since they're on top of each other, being divided, we subtract the exponents. So e to the fourth over e to the third is the same thing as e to the 4 minus 3, which means this comes out to 4e to the first, or 4e. Because again, as we know, writing to first power is pretty much irrelevant. In C, we have negative 5e to the negative 3x power, all raised to the second power. Whenever we have an exponent outside a bunch of terms in parentheses, or any amount of terms in parentheses, we distribute that power to all the terms possible. So we're going to apply that squared to the negative 5 and to the e to the negative 3x. So first things first, I'm going to have negative 5 squared, and then I'll have e to the negative 3x times 2 power. Negative 5 squared comes out to positive 25. E to the negative 3x times 2 would be e to the negative 6x. Now, one other property that you've learned and we went over earlier in the year is when we have negative exponents, we cannot leave them as negative exponents. So the way that we're going to fix that is to put it over 1. We move the power, or move the term that has a negative exponent, and we're going to move it underneath. So basically, we flip it underneath the 25, and we get 25 over e to the positive 6x. So the next handful of problems you see underneath are pretty much the exact same idea here, where we're just going to simplify. If you want to hit pause at this point, try them on your own and check the answers. By fast forwarding a little bit, feel free. If you need more explanation, just continue watching here and I'm going to walk you through these. So here we've got e to the 7th times e to the 4th. Again, when we multiply the same base, you add your exponents. So e to the 7th times e to the 4th becomes e to the 11th. 2e to the negative 3rd times 6e to the 5th. All that's being multiplied together so I can reorganize it. 2 times 6 can go nice with each other. And e to the negative 3rd times e to the 5th can go nicely with each other. We know 2 times 6 is 12. e to the negative third and e to the fifth, we add those up, we get e squared. So my final answer, my final simplification will be 12e squared. 24 e to the 8th over 4e to the 5th. All we're going to do there is take 24 divided by 4. That becomes 6. E to the 8th over e to the 5th. We subtract them. And that ends up coming out to 6e to the 3rd power. And last but not least, we have 10e to the negative 4x all raised to the 3rd power. We apply that 3rd power to both the 10 and to the e to the negative 4x. So we'd have 10 to the 3rd and e to the negative 4x times 3 power. 10 to the 3rd comes out to 1,000. E to the negative 12x. We cannot leave a negative exponent, so we're going to go ahead and move the e term underneath and have a final answer of 1,000 over e to the 12x power. So this is more just to kind of review some basic exponent properties, because as we move forward in this chapter, since this is all about exponential functions, you are going to see a lot more of these pop back up. But now what we're going to transition into is using e to evaluate expressions as well as to do some graphing with them. So you notice at the bottom here, we're going to use a calculator to evaluate these natural base expressions here. So what I'm going to show you here is how do we actually type these into the calculator to get some numbers out of them. So first example I have here is e to the 4th. So in order to get e to the 4th, what we're going to do here, so I'm going to clear out of this, pull up the calculator here and get that active. To type in e to the 4th, first off, let's just really quick talk about typing in e. In order to type in e, you hit second and division. And you'll notice, if you look above your division button, you'll see an e in a different color. As soon as you hit second and division, the e will come up automatically. All you then have to do is hit your caret for the exponent, type in the exponent of 4 in this case, and hit enter. Every one of these is going to come out to an irrational number of some sort, unless it's a power of 0, which anything to the 0 gets you 1. But anytime you're taking e to any power that's not 0, you're going to get an irrational answer. So if you get these big long decimals, it's not a big deal. So to kind of just write this out in terms of the key strokes, and you can see it here underneath the calculator screen. You're hitting second. You're hitting division. That's what gets the e to pop up. Your caret. And then you type in your exponent, so in this case it's 4. Now, when it comes to writing out your answers, anytime you have to evaluate problems with e, for accuracy's sake, and this is something we'll do a lot more once we actually get into the logarithms part of this chapter. I know typically when we round, some of you have a habit of rounding to one place. That's not super accurate. A lot of times we tend to do 2 places. With logarithms, we are going to actually go to 3 places, because a lot of times these numbers tend to be very close to each other. So just for the sake of a little bit more accuracy, we're going to go ahead and write out all of these answers in this chapter to 3 places if necessary. So 54.598 would be roughly our rounded answer there for e to the 4th power. Now, for e to the negative 0.09, it's the same sequence of steps. You type in second, division, your caret button to pull up the power, and then negative 0.09. So I will do that here real quick. So if you want to copy down those steps, again, I'm going to pull the calculator back up. So we'll see second, division, power button, negative 0.09. And again, you get another answer here. Again, it's irrational. So again, we're going to round it to 3 decimal places. So my answer for this, e to the negative 0.09 power, would be approximately 0.914. So that's how you type e into your calculator. And again, you will get pretty gross answers when you do this, but that is to be expected given that e is an irrational number. So you will see that a lot of times we're going to be using that throughout a lot of the chapter there. So that's a sequence of buttons here that you should get pretty familiar with. That's how we evaluate. Anytime you're told to evaluate, that's when we're going to go to the calculator, plug in some numbers, and get an answer of some sort. Now we're going to take a look at here using E as it relates to graphing. So if you want to flip to the next page here of your notes, you're going to see with the graphing, it is extremely similar to what we just did in the last section with exponential growth and decay, because ultimately these are still exponential functions. It's just that our base, instead of it being some randomly picked number, our base is simply E. So pretty similar here. If you can see the two different types of ways that these can basically turn out. So the first function that you see here that's already done for you is e to the x. The second function is e to the negative x. So that kind of gives you an idea as to which way these will point depending on your exponent. So since your base is always the same, that doesn't really give you a clue. If your exponent is going to end up working at as a positive exponent, it'll end up climbing from left to right and growing. If you are less than 0, you have a negative exponent in these natural base functions. These are going to show decay where they are decreasing from left to right. So we'll see that in the two examples underneath. So we're going to quickly here type these into the calculator just to review the buttons, and then we'll state our basic domains and ranges. So let's go ahead, graph 3a. So we have 3 times e to the 0.25x power. So we type into 3 to get our e, that's second and division. Use our caret, 0.25x, and we'll graph. So with these graphs, you can see sometimes they're a little bit different in that they don't flatten out maybe as quickly. It just, again, depends on the exponent and the numbers in front and back of the function, but it's pretty much the same gist. We had a positive exponent, so you can clearly see it is showing growth as you look at it from left to right. So we'll go ahead here and go to our table. So again, we want to pick enough values where we can clearly show the climb. So I'm not going to copy them down here just because I don't have a ton of room on my screen to do so, but we'll pick a few numbers here from the calculator. So let's see, -3, 1.41, -2, 1.82, -1, 2.33, 0, 3, 1, 3.85, 2, 4.95, 3, 6.35, and that's about all I can fit. So I'll go ahead and sketch that in. Now once again, we can quickly identify domain and range. So let's start with domain. You can see that it's pointing left, it's pointing right. Our domain goes from negative to positive infinity. Our range can be identified the same way that we did in the last lesson, and we're all basically going to look for what's being added or subtracted to the function itself. I don't see anything being added or subtracted, so it's going as low as just above 0, and it's pointing as high as infinity. So theoretically, there'd be an asymptote here, and that's as far as we can go. That would be 3a. Let's take a look here at 3b. So you can see there's a couple more pieces to it. So again, the biggest thing is when you graph them, just taking your time and entering everything in. So we've got e, so second division, to the -0.75 times x minus 2 power. If you want, you could distribute that through, so you don't have to have the parentheses in there, but ultimately it doesn't really matter. And then you have the +1 after it. So that +1 is going to shift the graph a little, bit, and will affect its placement on the axis here. But again, we see a negative exponent involved here, so we're going to go ahead and see what this looks like. Let's go ahead and graph it. So the fact that we have a negative exponent involved means we're going to see decay. So as we look at it from left to right, it's going to be going downward. So we'll go to our table. You can see we have a lot of really high y values. So again, we want to find stuff that fits. So I'm going to start here with see, 5.48 will fit. So I'm going to scroll and make sure I can fit a couple of numbers here, and we'll plot. So again, I'm just going to copy the table. I'm not going to rewrite it, but we can read it off the screen here. So 5.48, 3.12, 2, 3, 1.47, 4, 1.22, 5, 1.11, and you can see it just continues to decrease towards 1 from there. So to finish this up, we're going to quickly identify our domain and range. Once again, our domain is running infinitely in both directions. So domain is from negative to positive infinity. Our range, again, based on that plus 1 we see tacked on to the function, that means if we look at our graph, it's going to be as low as almost 1. We see that in our table, if we were to keep scrolling, a bunch of values that are going to approach 1 but not quite hit it. That's as low as it goes, just above 1, and will increase, you can see it pointing upward, all the way to positive infinity. So that's the introduction there from Lesson 8.2, all things with the natural base e. You're certainly going to see a lot more of that as we go through the next several sections, as we dive more into exponential functions, logarithms, and all those sorts of things. So once again, you have a short homework assignment that goes with this that I would recommend that you try some of the problems, check the answer key, and check in with me in regard to any questions you might have. Your small graded assignment that goes with this, again, you will find posted on Schoology and instructions on what to do with that from there. So thanks for taking the time to watch. Again, if you have any questions with anything, shoot me a Schoology message, shoot me an email, or feel free to set up a video conference with me if you need further explanations. Thank you for watching, and we'll see you next time.